Good evening. My name is Jack Rooney, and I know I've had the pleasure of meeting some of you in the past. Some I've known you for a long time, but I'm not a technical person. I'm a 25-year sales guy, so don't hold that against me. But I spent my whole career hanging around smart people like yourselves. A couple logistical items first. We've got parking vouchers up here, so make sure to get one before you go, and you can just hand that to the parking attendant when we're done. Also, there's drinks and snacks in the back, so help yourself. When you have a question later on in the presentation, please come up to one of the microphones to ask the question. It's my pleasure to introduce Jim Daugherty, who's new to the area. Jim has been in the IT business for 30 years. He's going to be our main speaker tonight. He's going to speak to us about unit testing in the .NET world. And again, Jim recently moved here and is currently at Horace Mann. And I forgot to ask you, Jim, but I'm sure you'll mention in your presentation some bits about where you've worked in the past. And it's a pleasure to have you here in Springfield. And this is our company that I'm with, Capital Strategies. This is our first night for sponsoring the event, and I wanted to thank you all for coming. So, thank you.
Yeah, I have been doing software for a long time. I started as a developer, and I've never quit being a developer, even though I've gotten some other roles over the years. I really like to write code, and I was pleased to speak about unit testing. I found that that's been a godsend since I started doing it for the development. I've been able to share it with other teams that I've worked with, and have more or less got consensus that it's a good thing. So let me dive right into what unit testing has to do with .NET. Unit testing, it did not start with .NET. It kind of came a little bit late to the game. Java had it. Some of the other languages have it, but Microsoft is really getting on the bandwagon and giving us some tools. So we'll look at some of those tools that makes unit testing easy in the .NET world. Okay, so first, why do unit testing? We can do it as developers in secret. We can sneak it in, try to do it, and there's benefit there. But it's always better if you can get an organization to go with you. What this is meant to portray is this shows more of a waterfall approach, but still, requirements gathering. If we can find our bugs in requirements, it has the smallest cost, right? We fix them before we even write any code. You look at the architecture, when we're doing the architecture of the project, and as we basically move on down through a project, it gets worse and worse. Even in an agile world, that's still true. Once we get out of our construction phase and we actually get it into UAT, it's more costly than it is if you find it in your construction phase, and it becomes much worse in production no matter how you build the software. So this is the information you share with the business and try to convince them that TDD is a good way to go, or unit testing. Now, why do we do it from a technical perspective? Well, tests encourage better design sooner. When you're writing your test, you're going to think about the design so that it's testable. And to make your design testable, typically that means you're doing a better design overall. Also, tests are the best documentation. On the teams that I've used in the past, we get to the point where our technical documentation almost becomes zilch. We use the test to read and bring new people into the team. You sit them down in front of the test, they can see how you're going to call the different modules you're going to use. What was the purpose of doing it? Because the tests show that. What's the purpose of why I wrote that method? You can write the documentation, but there's that impedance mismatch that you run into with that, because the way you describe what you want doesn't really always exactly match the code. It's been said many times that the best documentation for code is the code itself. It is very precise. It's exactly what it's going to do. So test, communicate that very well. Tests are your safety net, both for everyday use and to give you major refactoring freedom. What I mean is, if you're writing the test as you go every day, they cause you to think about what you're building. You immediately get those tests, and if you make a change with something you build that affects something else that's under test, you immediately get that feedback, so it makes you do a better job of writing your code the first time. Major refactoring freedom, what that means is that if you have a complete application under test and you go in and you have to do some major refactoring down in the guts, you have all these tests that allow you to be absolutely positive that the tests you make have no effect on any of the code that was depending on what you wrote. So from a technical perspective, lots of good reason to do TDD. One thing I haven't talked about is time it takes to write the code. Does it take longer to write tests before you write the code? Well, if you look at that little sliver of the effort, yes it does. You're writing more code, it takes more time. Now, some people will argue that you'll write it better the first time, which will be faster in the long run, but it becomes a net savings upon your first release and your second cycle. That's how fast it gets nowadays, because the compilers are faster, you can test your code faster. When we first started doing it, it was hard to make that call because it took a lot longer to get the payback because it just took so much time to see that your test passed or failed. But now we're at that point where it's almost instant. It's well worth the investment. Test types. We're going to talk about unit testing, but there are other types that you ought to know about. Unit testing is where we test an atomic unit of code, so we're testing only a small piece of code. Integration testing is where we allow that test to go to other modules in the area. Okay? Basically friends of the class that you're working with typically. User acceptance testing, that's where the end user is testing your code to make sure that it matches up to what they were expecting it to do. And then TDD tests. TDD tests imply something slightly different than unit test. TDD test, there's a product out there, it's an open source called SpecFlow that you can load into your Visual Studio environment and allow you to write tests in very much English fashion that your end users can actually read, and it generates things that look very much like unit tests. Those tests are expected, though, to go down through the whole tree, and you write those tests first, then you write the code to pass the test. Now you can certainly do that as part of unit testing, but that's when you step into the real world of TDD, is where you're actually writing these tests that you can print out and hand to your business partner, and they can read through them and say, that's exactly what I want, yeah, make that work. Then you start writing your code to pass those tests. Then what you do is you wrap your code around with unit tests as well as you're going down through the layers, with that being a specification as opposed to a test. A unit test is a piece of code that invokes the method or class being tested and then checks some assumptions about the logical behavior of the method or class. A unit test is almost always written using a unit testing framework. I read that verbatim because I'm taking a quote out of a book. It's a very good book, The Art of Unit Testing. You can get it as a PDF, by the way, and keep it handy all the time. It's a very good book on unit testing, and we'll walk you through the exact steps. A lot of what I show you will be in that book. I refer to it commonly myself. And it does define unit testing very well. We are testing something small. We want to know that it works and the method will work under different things being passed in. Unit test versus an integration test. This is important because one of the tendencies when you first start doing unit testing is to allow it to become an integration test. It's easy to do, and it'll cause you problems down the road. Two reasons. One is an integration test usually goes all the way through your hierarchy of objects, all the way down to get the real answer from a real database perhaps, or makes the actual call to a web service. That's going to be slow. It's going to slow you down your desktop, make it harder to do your unit testing because you just get frustrated waiting. It also means that whatever you're calling out there has to be configured just right to pass your test. If somebody makes a change on their web service in some way that doesn't pass back the exact data you're expecting, your unit test breaks. Unit tests are meant to be written to where they always work. We'll talk about some rules. Unit tests should target the logical code, and logical code, this is talking about what do we unit test. We don't unit test property getters and setters. We don't unit test methods that don't do anything other than grab a different value and pass it back. Only if we have logic embedded in that method are we going to bother wrapping it in unit test. If you try to unit test every little piece, again, you'll get frustrated and stop doing it. And honestly, stick with it. Don't let those kind of frustrations get to you, but there are certain things just don't mess with. If you're not going to get value out of it, don't write the test. Okay, so properties of a good unit test. It's automated and repeatable. So you hit a button, they run. You hit the button again, they run. You close the project, you open it up, you hit the button, they run. They just run. that's why they work so well, is because nobody has to go in and check to see if the database has the right data, anything like that. It's easy to implement. This is a bit of an exaggeration for every case for certain. Most of your unit tests are easy to implement. You will run into struggles as we implement, especially if you're dealing with legacy code. They present particularly fun challenges, okay? It can be run in the future. We kind of talked about that. It can be run by anyone. Again, there's no setup. If you open up a project and it has unit tests, you should be able to hit run and it just runs every time. No special setup on the desktop. And I won't go into the nitty-gritty details there, but again, runs as a button and it runs quickly. This is one of the reasons why we don't like integration tests. Integration tests run slowly. If you get into the world where you have an automated build server, you'll run your integration test maybe nightly, maybe hourly, but not every time you check in. You'll run your unit tests every time you check in. Integration tests, because they run slow, they take longer time, they may need setup. You run them only every so often. So, some glossary terms for unit testing. One is that as you're doing unit tests, you have to understand a concept of faking. And faking is where you take friends of your class or method and you basically create a fake of those so that your method under test doesn't go outside of itself when you run the test. Why do we do that? Again, we're trying to avoid the integration test. We want to make our test atomic. In other words, we want to test that method that's in the class for what it does, not what its friends do as well. If we have everything wrapped in test, then we don't have to worry about that as long as they respond appropriately. So a fake, there's two types of fakes. There's a stub and there's a mock. The difference is where we go to determine if the method worked. So the first thing that we check is, or first one I want to talk about is the stub. So if I have a method that has a call out to a friend method that returns simply an answer that it then responds to what that answer is. In other words, in the application we were going to work through an authentication service. So as I go in and I make a call to add that project, it calls out to an authentication service that says, yeah, the token you passed me is a valid token of a user that should be able to add a project. Well, I don't want to let that call occur. It may well go to a stub. What I would do in this case of an authentication service is that I would set up a method that would return true. Yeah, that user is authenticated to make that call, to add that project. Then I would also have that stub in such a fashion that I could also pass back a false and say, no, this user isn't right. Thus allowing me to write two unit tests. One to test it with that this is a valid user, and then test this method with an invalid user. So when you think about that, what that allows me to do, it doesn't matter what that token is that I pass in. It doesn't have to be in a database set up appropriately. I don't have to pass in two different tokens, one being in the database, one not being in the database. It doesn't matter. I can tell it to return back what I want and see that the logic inside the method I'm testing is valid. Now a mock is different because what's going to happen is with a stub, when I make that call, it's going to come back and my method's going to give me back either an error message that says invalid user or return a value or something to let me know that that was an invalid user. It's going to go ahead and do its normal processing and return that value to me when it gets done. And I can test that returned value. A mock, on the other hand, I'm actually going to ask the mock, did you get called appropriate? So imagine if you have a different web service that's going to save the project off. When I make my call in and I fake out that service with what's called a mock, what I really want to know is, did it make its call correctly? So what happens is you write the mock and it looks exactly like the service. Your application makes that call to the mock. Then I ask the mock, did you get called and what did you get called with? Were all those parameters correct? So if I pass in the name of the project and its start date, I will ask the mock, did you get a name and a start date? And if it says yes I did, then I passed my test for testing that it had a valid call out. So now I know that my understanding of the contract I have with my web service, I'm calling that contract appropriately. If I have tests wrapped around my web service and it passes all of its tests, I should have working code. Okay, so I'm just creating a class library project, and then we'll add a test project to that. So what I'm doing here is in the naming, and again, the Art of Unit Testing book goes through this, and it has a wonderful pattern you can just follow. We put on the end .unit test. It's not required technically, but it does tell us exactly what this module is, this project is. So we create the separate project. As you can see, we have unit tests, then integration tests, and then specifications if you're using something like SpecFlow. The reason we do that is so that on our build server it's easy to say, hey, run the unit test buried in this project. Don't run the integration test. Nightly build, run both. Okay. So what I did there was I changed the name of the class to be named the same in my test, the same as my class up above, so that you know exactly what it is. And to be quite honest, I messed that up because we want to put the word tests on the end of that so we don't get into namespace stuff. There we go. Yes. Okay. Now notice that in this class we have some attributes attached to the code. Let me get down here. We have an explanation for those here. Okay. So we have test class and test method. Each test method we will align with one of the tests that we want to do against one of our methods in our actual DLL in our class. The test class, that indicates to C# that this entire class is all filled with unit tests, which then lets it tie up to the test manager that's part of the application, part of Visual Studio. So the first thing that we want to test, go back to my PowerPoint. I mapped this all out so this would go fast. One of the other things I want to cover is that in unit test we have the idea that we assemble our test, we activate or act on our test, and that we then assert. Assert is a unit test method that we'll call that we can do certain tests on. Comparative tests of equal, not equal, is null, not null, things like that. Our naming convention that we use on the class methods, not too far, is that we put the method name that we're testing, so that whenever we want to look at what tests were written for a particular method, when we look in our class, we can quickly identify all the tests for that particular method. Again, remembering that as we write these tests, we are writing a form of documentation for our fellow developers as they come along and look at our code. So this makes it very easy for them to look at all the methods that are associated with with the method that they are trying to figure out what's going on. And then the outcome expected. Again, success, invalid address, those are pretty simple. It gets a little messier after you do it a while to understand how can I put something in there. Don't be afraid to make that a really long method name so that people understand what it is that you're trying to test. Here's where we was talking about the attributes. One thing I call out, test initialize. That's set up before each test in the class. So what you have is you have this mechanism that they've built into the testing framework that allows it to run the test initialized before each test, so that if you want to reset some variable that you're going to use over and over again. One typical use of that is that I'm building a value object that I'm going to pass in as a test value object, and it may get modified during the test, that I reset it. So I always just set all those properties back, and that'll happen before every test that's called. There's other methods as well. There's a method that is ran, the test class, that's ran when the test is first started for that entire class. And then there's also teardown attributes as well that you can use both at the before and after every test, before and after the actual class is built. One other thing that I want to call out here before we get into the code is expected exception and then a type of. This is a way to test for errors being thrown. One thing you might not have thought of if you haven't done unit testing before is that if you want to test that you're throwing the appropriate errors, well, you don't want it to actually throw an error. You don't want to have to take the time to wrap it in a try catch that's empty or that reports out. A lot of work. This takes care of all that. It'll actually catch that error for you, provide the type in. If the type matches that, then the test actually passes, even though the method you're testing threw an error. Then we have the test cleanup that I spoke about and class cleanup. Okay. So the first thing we're going to test, and knowing that we were having a short time and now being even shorter, I'm going to leave the easy type of unit test for you guys to discover on your own, where you just write a call to a method and it returns back a 1 or a 0, and you do an assert. If it's equal, you pass. And kind of go to some of these a little more difficult but fun to see type of tests. And as you see, I love to cut and paste. So in my assemble part of my first test, which we'll call the add project method. And what we expect is throw no name error. Okay. So first thing I have to do is I have to create my projects class. And then I want to call it with up. Now in this particular case, I'm not going to have an assert because I'm trying to catch that error. So when you do normal unit tests where you're checking a return value or something like that, you would do an assert to check the state of something. In this case, I'm looking for an error is being thrown. That's what my expectation is. I know I have to build something to do a project. I want to check that the name is not null, empty, anything like that. Notice though that if we look at our project, there is no method add projects to it, add project. If we right click, we can tell it to generate the method stub. Now if we go back to there, okay, maybe it put it someplace else. Do what? I see, sorry. Thank you. We'll see if that goes. All right. So that's a feature that Microsoft has put in to assist us in TDD, is that you can write your test first, put the method that you're going to be creating, right-click, say generate, it'll create your stub for you. Now if we run this test, in theory it should fail. And it did. You can right click down here and then we can look at our details of this. It threw a no name error, was what we were expecting, but we got a not implemented exception. All right. So in TDD, the first thing you want is a fail, so you know you have a test that is close to what you want. So now we'll go over to here and we'll put in the code. And up here, another nice feature that Microsoft's given us is that I can click on this first button and that'll run the test in context. What that means is if my cursor is within a particular method, it will only run that one test method. If I put my cursor at the class level, it will run all the tests in that class. The next button over will run all tests. It'll run every unit test we have. The third one is run impacted tests. You have to turn on a feature to get that to work for you. What it does is it actually tries to track all the dependencies of your tested code, and it'll actually extrapolate and run just those tests it believes that are impacted. It does a pretty good job. It will miss on occasion. All right, we're still failing, so we'll look into this. Argument exception. So I wrote my test incorrectly. and now we're passing. So we are getting back our application error if we pass in an empty string or no null or anything like that, then we'll get back that. And again, we could write a few tests here to check for that error for the different combinations of the project name being blank, being null, whatever that we're checking for on the other side. We could put some spaces in there really to test out Microsoft's white space test. Okay. So we already covered that. So let's add some security. We talked about this a little bit before. So what we want to look at is the possibility that this person who is making that call to our class is or is not authorized to be adding a project to our list of projects. So what we'll do is, again, I'm going to rely on the exception. So we have to decide what our design is. Are we going to pass in our user token with every call, or are we going to pass in the user when we instantiate the class? I'm going to choose to do it when we instantiate the class, that after we'll do it in the constructor of the class. So what we do is we go up to here and we say, well, whenever we create a new project, pass in a token that represents the user. Probably more appropriate if it was a GUID, but my program. So when I instantiate that, it says, oh, well, you don't have a projects that has a constructor like that. So I'll just ask it to create one for me. Now I have the user token. So in my world, what we have is we have a web service out there that we would pass any token to. It would go in, check the login database to make sure that they've been logged in recently and all that. I don't think we really have time to write that, and besides, I'm writing a unit test. I don't want to use that anyway. So what do? We know now that we're going to have to fake this out. We want to be able to control whether or not, when we run this test, it gets whether the user is valid or not. So this is what we call a stub. Now, there's another concept that we need to understand as well, and that is an external dependency. That's what I described, that web service that I would call as an external dependency, even though I may have a stub in my code that's actually an adapter calling that for me, it's external to me. So what we have to do is we have to do what's called dependency injection. So what that gives us the ability to do is it allows us to say, when you say you want to call that web service, here's who I want you to call. Now, it's not a bad design normally anyway. That allows you the opportunity to pass in multiple things that could actually answer the security question based on a token that's passed to the application. So it's not a bad design. It's relatively cheap for us, and it makes us testable. That leads me to, there are testing libraries out there that would reduce the need for this. TypeMock is one. Telerik has another one that is coming out. Microsoft has in research moles. That one's free. That will actually slip into the layer and allow you to redirect any call you wish without doing any design change. Be careful of those. You start losing the benefit of doing good design if you misuse those. When you get to legacy code, those things are fantastic, so definitely look at those, okay? But for what our example is, we don't need to go there. Again, we've kind of talked about this. Sorry for the disjoint in this, but I was trying to get ahead there. Stub and mock we've talked about. I'm going to skip down to here. All right. So let's create our stub. First thing we have to do is we'll go into our test. And this is a personal way that I do this. If I'm going to write an actual stub myself or a mock, I try, provided they're not too complicated, to leave them in the exact same file that I'm working my test in. Why? Again, I look at these tests as documentation. I don't want the person following me to have to bounce around and look at 10 different files to find what they need. I want them to be able to see as much as they can right here. With the nice tools that Microsoft gives us to do region hiding and closing, and even be able just to close a class up, you can keep it to where it's pretty concise, and if they want to open it up and look at it, you can. So when I'm writing my unit tests, I try to remember that this is actually a form of documentation that's going to be passed on. Okay? So with that said, we'll create a new stub. And since we're writing a test that is going to, we want to see what it does when it fails. We're going to return false. Okay? So there's our stub. That's my service. Now, notice we have a problem. How do I let this application know, this class know, that I want to use that stub rather than the service? So what we'll do is, we'll create an interface. Security service. Something's wrong. Any help from the audience why I'm not finding my interface? No? There we go. So it implements that interface. Then what we'll do is we'll go into our class and we'll create a form of dependency injection. Since security is related to the user token, I'm just going to use it in the constructor. I'm going to pass in the security service. Okay? So what I've done is, and now in my constructor, I am actually passing in the service that I want to use. So under normal circumstances in production code, what we would do is we would pass in a legitimate security service that would implement that interface. I'm going to pass in my fake so that I get the answer I want back out of it. Now, just because I don't like constructors to throw errors, I'm actually going to do the security check inside of each of the routines that gets called, in this case, since I only have one. Now I go back to my tests. I got problems because now my constructor wants a security service. So I need to create one of those. Okay, so I should be expecting out an application exception. In this case, you'd normally want to put the string out there exactly, but I tried that at home and I misspelled the strings too often, so we'll just go with it like it is. We should get an error here because I had another unit test that I didn't go in and fix this for. So it did not throw the expected system application error. It passed. Anybody know why? Very good. So this was supposed to be an example of how writing tests help you while you're even writing the code. How long did you know I didn't do that and sat there quietly? Okay, okay. There you go. Now we pass. We get our application error thrown. Okay? And I know you indicated we were going to ask questions at the end. Is it okay if I ask for questions so far? Oh. All right. Paul. I don't think so. Oh, it is. I'm good. Okay. All right, we only got 2 minutes left. No other questions? Okay. Most value I can give in 2 minutes. Another form of dependency injection. If we were also going to call the service that would actually add the project to the list, again, we're going to call a service that may add that, or we're going to make a call to a database. What we want to do is we want to build a class that has a call add project to it. So we'd call add project in to do that. Another form of dependency injection that you can offer up is that when you build that class, make those methods virtual. Then you can inherit from them and override them and have them do what you want. Another thing that I'll cover very quickly is this stub is weak because I can't reuse it to do true. So one thing that you would do is you would implement that interface, then you would also add another method of set what I want to return. All right? So that what we would do here is something simple like I would normally use a property for this, but I started typing this, so I'm going to go with it. I can see I have an error, but there, should go away. All right, went away. So what you would do with this makes this stub more useful to me. Now I can write multiple tests and just call down the stub and say, hey, set this. Another way to do that is to make it in the constructor. That way you write one stub. Again, there's many principles by which you can do unit testing, and I'm sorry I won't be able to get to some of them. Writing mocks and stubs takes time, so make them as simple as possible. And also, it's important to look for seams in your application where you can put the mocks at. It's not always possible, especially in legacy code and time constraints, to wrap everything in unit tests as you're starting. But if you can look for seams in your application, places where you can insert these and build a big interface and wrap that up, that makes this job easier. Microsoft offers you some real nice stuff. If you turn on code coverage, which Google it, find out how to turn it on. It's not really intuitive, but you'll find a way to turn on code coverage. As you run your test, you can actually look at the code and color codes that code to show you what actually got tested by a test and what didn't. And that also drives to this percentage of code coverage. At Horace Mann, on the SOL team, they're doing continuous integration, and we're going to be putting a rule in place that means they can't check in code that decreases their code coverage. So we'll constantly be improving. Is it already there, Scott?
Not yet.
Okay. So we're going to be adding that in to constantly improve the code coverage as we go. So, again, 75% code coverage is our starting goal. In talking to other companies that are out there doing it, they get into the 90s. Right? Some nice things to look at. SpecFlow. Rhinomocks is a mocking framework. They are out there. What they do is they build stubs and mocks for you and allow them to do the test for you. And there's the guy who wrote the book, Art of Unit Testing, is there at the top, and magazine, code coverage, that'll be there too. Any last minute questions for that wonderfully brief wrap up?
Do you have a preference that you think makes it easier for testing with dependency injection containers like Unity versus one of the other ones? Like the Castle Windsor project had one, and then there's a few others.
No, I don't. I've done most of it without containers. The reason is that the containers, again, they act a lot like some of the mocking frameworks. I'd like to understand the code, and I always start off that way. And then the containers will help make it faster.
Yeah.
But I haven't ended up using them that much, so I really can't speak to that. All right, thank you.